Alright, welcome ladies and gentlemen. Today we are looking at 10.2, which is graphing logarithmic functions. So we talked about a lot of the attributes and definition stuff for 10.1. And today we're going to look at just the graphing section of it, which of course, as you know, means our next slide is this one. So, I want to make it perfectly clear. This is as easy as it looks. All of these things do exactly what it looks like they should. If it's inside the parentheses with the x, it is horizontal. If it's outside the parentheses, it is vertical. If it's multiplication, it's a stretch or compression. If it's addition or subtraction, it's a translation. If it's a negative sign, it's a reflection. Those are the only possibilities. So, the way I want to talk about this one today is to just take a look at a pure example. This guy. -4 log base 2 of x plus 2 plus 3. So, what's the first thing we see? From left to right, I see a negative sign out front. Immediately, vertical reflection. We're reflecting over the x-axis. What's the next thing you see? I see a 4 next to the minus sign. Well, is that inside or outside? It's outside, so it's vertical. Is it addition and subtraction or multiplication division? It's multiplication or division, which makes it stretch by a factor of 4. Next thing I see a plus 2. That's on the inside. That makes it horizontal. It's addition. That makes it a translation. Remember, it's inside the parentheses, so it's backwards and stupid. You would think that plus would go right, so it's going to go left instead. Horizontal translation, left 2. Finally, I see a 3 on the outside. That makes it vertical. It's addition. That makes it a translation. Up 3. So there are 4 different transformations that this graph has. A vertical reflection, a vertical stretch, a horizontal translation, and a vertical translation. That's all there is to these problems, guys. I promise, it really is as easy as that. If you just take a look at it, work through it, you've really got this. I will say, however, question number 8 is going to require you to do an exponential regression, just like we did on the zombie project. If you don't remember how to do that, go back, take a look at that video. It will be made public, so you'll be able to find it on my YouTube page if you need it. Secondly, the biggest thing that we need to remember is that just because it looks difficult doesn't mean you can't do it. In that vein, problem number 9 is legitimately difficult. It is harder than any other problem that I've put on a homework assignment. However, if you take a look at an example, you work through an example problem, you work through a step-by-step solution, you can do it. It is a hard problem. And it is actually one of those real-world applications that I've been talking about. However, because it is a little outside the scope of A, what I've taught you here, and B, what the TEKs say you need, it is going to be an extra credit problem. So if you get the other 9 problems right and you don't get that one right, that's okay. But if you get all of them correct, all 10, then that will be extra credit. So, with that, Wildcats, it really is as easy as I make it look on this slide as far as the basic questions go. Question 8 requires you to pull out some past knowledge from the last unit. Question 9, like I said, legitimately hard question, but if you work through it with the example and the step-by-step, that one's worth extra credit. Good luck, Wildcats.